Okay, let's start with number one. Write an interpretation of the given limit. So this is can be read as x approaching 3, the value of the function is almost 7. So this is part B. For question number 2, given the function f of x, so it's about finding the whole and vertical asymptote. So before we decide, we need to factor the numerator and denominator mentally or by calculator mod 5-3. X and x, the numbers are +4 and +4, the product is 16 and the sum is 8. For the one down, the two numbers are +2 and +4. The common between numerator and denominator is x plus 4. So x plus 4 equal to 0, then x equal -4. And this is the whole. The one remained down, x plus 2, then x equal -2. This is the vertical asymptote. So x equal -4 is the whole and x equal -2 is the vertical asymptote. Question number 3. The function f of x equal x squared over x minus 2, which the following represent the equation of vertical asymptote. So the vertical asymptote, first we check factoring, nothing to be factored. So we solve the denominator to find the vertical asymptote. So only x equal 2. Question number 4. 3x divided by x plus 2 all to the power of 2. So it's about finding the limit when x approaches -2 from the left. So as we know, if we replace x by -2, it's gonna be undefined or infinity. So what do? We take a number that is less than -2. So let's say -2.001. And we plug in. So 3 multiplied -2.001 divide -2.001 plus 2, or any other value square. Just we need to know the answer will be positive or negative infinity. Do calculations. This is always positive, so it depends on the numerator. 3 times -2 point is negative. So the answer is negative infinity. Also, I'm gonna take 1 point to the right of -2. So let's say -1.999. So replace again 3 into -1.999 divide by whatever square, because whatever you put here square, it will be positive. So it depends, as I said, on the numerator. 3 times negative, it's negative. So in both cases, it's negative infinity. Number 5, find all the asymptotes. All means vertical and horizontal asymptote. So first, we cannot decide before we do factoring. GCF is 3, so x plus 2. X squared minus 1, mentally or by calculator, since it's quadratic, by calculator or mentally. So the numbers are -1 and +1. Nothing to be cancelled, so we are sure that the values of the denominator are the vertical asymptotes. So x equal 1, x equal -1. So these are the vertical asymptotes. Horizontal asymptote, it depends on the degree of the numerator and denominator. The degree here is 1 and the degree here is 2. This is the fastest way. So the numerator up is less than the numerator down, so the horizontal asymptote is 0. I think the answer should be modified. So 1, -1, and the horizontal asymptote is 0. Question number 6. Find the vertical asymptote. So first we factor. The two numbers are plus and -3. And the one down is x and x. -12 and -1, so it's -4 and +3. The +3, x plus 3 cancelled, which is the whole, but it's not our subject because we are looking for the vertical asymptote only. So the one left down is x minus 4, solve it, then x equal 4. Question number 7. Find the vertical asymptotes. It's already in the factored form, nothing to be cancelled. So x4 equal to 0, or 3 minus x equal to 0. So the first one, x equal 3. According to the x to the 4, so fourth root, or generally x equal to 0, whatever you do, fourth root, whatever you do for the 0 stays 0, so it doesn't matter. So 0 and 3. Question number 8. Len 0 to the right should be written as limit len x when x approaches 0 from the right. The graph of the len is like this. This is x and this is y. So this is 0. 0 from the right is this one. And the graph approaching 0 from the right is this one. And it seems to be going down, so negative infinity. Number 9, find all the asymptotes. This is one, this one is repeated. And as we mentioned, the vertical asymptote x equal 1 and x equal -1. The horizontal asymptote is 0, as we mentioned earlier. So here I can say the horizontal asymptote is 0. For number 10, find the vertical asymptote. And the question is about two cubes. I'm gonna remind you by the rule for factoring two cubes. So let's say a3 plus b3 can be factored as a plus b into a2 plus ab plus b2. So here the a is x and here the b is 2, because 8 can be written as 2 to the power 3. So x over 2, sorry, divide by x plus 2, and in the numerator we write x plus 2 and the other bracket The first square is x squared plus a times b, so x times 2, 2x, plus the second square is 2 squared, which is 4. As you can see, x plus 2 with x plus 2 cancelled, so the answer is x squared plus 2x plus 4. There is no denominator, it means there is no asymptote. There is no vertical asymptote. Number 11, 5 divided by infinity. So any number divided by infinity is 0. And if you have some properties, infinity divided by 1 is infinity. Infinity divided by negative 2, let's say, is negative infinity. 1 divided by 0 is infinity. Negative 1 divided by 0 is negative infinity. 0 divided by 1 is 0. E to the power negative infinity is 0. Analysis: any number to the power negative can be written as 1 over positive e to the power positive infinity. So this is infinity. 1 divided by infinity is 0. For number 13, e to the power infinity is infinity. Well, e is a number, so any number raised to the power infinity is still infinity. Number 14, ln limit of x squared minus 2x plus 3 over 2 minus 5x plus x squared as x approaches infinity. This reminds me by the horizontal asymptote. According to the rules, degree up is 2 and the degree down is also 2. So the value of this limit is divide the coefficient by the coefficient. So can be reduced into ln 1 divided by 1, which is 1. Ln of 1 is 0. Number 15, the exponential function has the following graph. So if you have negative or positive number, this means the graph is shifted down 5 units. And this is the horizontal asymptote. And the horizontal asymptote, the equation is y equal negative 5. This is supposed to be y equal negative 5. Shifted down 5 units. So the horizontal asymptote is y equal negative 5. IVT, 3 conditions to be satisfied to apply IVT. One of them, the function f of x should be continuous in the closed interval, not the open interval. And the second condition, f of a shouldn't be equal f of b. For number 17, it's about the IVT. Before I find C, I need to check for the IVT can be applied or not. So first I'm gonna replace 4. So f of 4 equal 4 squared minus 2 into 4 minus 7. 16 minus 8, 8 minus 7 is 1. So f of 8 is 8 squared minus 2 times 8 minus 7. And the answer is 41. 8 is between 1 and 41. So IVT is applicable or can be applied, since also the f of 4 is different from 41. So f of c, replace c instead of x or leave it, doesn't matter, is equal to 8. Take it to the other side. C squared minus 2c minus 15 is equal to 0. Finding the value of c, calculator or factoring c and c. So negative 5 and positive 3, from which we can say c equal 5 or c equal negative 3. We need to check who is rejected. According to the interval 4 and 8, c is accepted equal 5 and negative 3 is rejected because it's outside the range. What is the least number of zeros for number 18? It depends on changing the signs of f of x. So from positive to negative, the function might have 1, 0. From negative to positive also we might have 1, 0. Plus already the function here at x equal 1 is 0. So possibly the least number of zeros is 3. Number 19, the function v, when it equals to 11, I need to find the interval. So I go and search for the function v where the 11 is located. The 11 is located here between 10 and 14. So the t is in this interval, 7 to 8. For number 20, it's exactly like number 17, so no need to repeat. So we go to number 21. Average rate of change, the average rate. The rule is f of b minus f of a divided by b minus a, where this is a and this is b. Let's find first f of 1, which is square root 1 plus 1, which is 2. And we need to find f of 4, so square root 4 plus 4, which is 6. Replace in the formula, so 6 minus 2 divided by 4 minus 1. So it's 4 divided by 3. For number 22, instantaneous rate of change. So the rule is limit f of x plus h minus f of x divided by h when h approaching 0. And remember the x is 3. So we're going to find f of 3 plus h. We replace, instead of every x, 3 plus h. So negative 5 bracket 3 plus h plus 1. Simplify negative 15 negative 5h plus 1. And f of 3 replace instead of x3, which is negative 15 plus 1, which is negative 14. Put them all in the formula, limit from h approaching 0. So negative 15 minus 5h plus 1 minus, open bracket always, negative 14 divide by h. We're going to have plus 14 with minus 15, it will be negative 1. With the positive 1, it will go minus 5h over h. H with h cancelled, so the answer is negative 5. Find the derivative, number 23. The derivative, which is g prime, is equal limit when x f of x plus h minus f of x when h approaches 0. We don't have x, so generally we're going to get f of x plus h. So f of x plus h, we replace x by x plus h, but we don't have something to plug in, so the answer is 6. If I have, for example, 6x, I'm going to remove x and I replace x plus h. But we don't have x to replace, so the answer stays the same, 6. So g prime is equal limit when h approaches 0. F of x plus h, we mentioned 6 minus, the original function is already 6 divided by h. So 6 minus 6, 0, divided by h is 0. So the derivative is 0. Twenty-four. Estimate the derivative at x equal 3.5. We don't have 3.5, so we take the interval 3 and 4. 3.5 is in between. So y2 minus y1 divided by x2 minus x1, or f of b minus f of a over b minus a, the same. So we're going to have this is y and this is x. So 595 minus 476 divided by 4 minus 3, which is 119. Okay, fill in the blanks. A vertical asymptote occurs when the function grows without bound as x. This is the vertical asymptote. The y goes to infinity or negative infinity when the function approaches the vertical asymptote. This is the vertical asymptote. Let's say x equal to. So we're going to find the function going without bound as x approaching this value. The notation means the function increases without bound near x equal a. That's the same thing we explained there. When x approaches the vertical asymptote, the function goes without any bound to infinity or minus infinity. The horizontal asymptote describes the behavior of function as x goes to infinity, same meaning. When x approaching infinity, the function f of x, the value is L, which is the horizontal asymptote. So the value of the function is L, which is the horizontal asymptote. Number 5, the IVT applies when a function is continuous on the closed interval. This is the first condition for the IVT to be applicable. The IVT guarantees that if f of a and f of b have opposite signs, this is the second condition when you are getting f of a equal to and f of b equal negative something, then for sure when they are different and negative, then for sure it will cut the x-axis. So to cut the x-axis or have c in the interval of a and b, the f of a and f of b must be of opposite signs. Number 7, the average rate of change of a function in the interval is the change in the rule of average rate of change f of b minus f of a divided by b minus a. So what is f? Is the y. So you can write y's. What is y? The output divided by the change in x. What is x? The input, which is the same meaning as b minus a. Number 8, the instantaneous rate of change at a point is found by taking the derivative. Rule instantaneous, as we mentioned up, limit when h approaching 0. And we said the instantaneous rate of change is the derivative itself at the certain point. Number 9, the derivative of the function represent its, as we mentioned in number 8, represent its rate of change. To be more accurate, instantaneous, but it's fine. Common definition for the derivatives are the symbols for the derivative, as we know, y prime. If the function is y, then the derivative is y prime or dy by dx. If the function is f, then derivative is f prime. Number 11, the derivative at a point can be estimated by finding the slope of the secant line. What does it mean? As we mentioned, if you have any graph, if you are taking these 2 points, then the average rate of change is the slope of the line passing through these 2 points, which is, we call it generally secant. The line that crossing any 2 points is called the secant, while the instantaneous is the slope of the tangent line. Number 12, a numerical estimate of the derivative can be found using the difference quotient. What does it mean, the difference quotient? F of x plus h minus f of x divided by h limit when h approaches. This is called difference quotient. Limits when x goes to infinity, part A. So it depends on the rules when the degree, comparing the degree of the numerator to the degree of the numerator, the three cases. So here I need to multiply first, but I shouldn't multiply all of them. I don't need all of them. Just I need the x with the x because I need the degree of the x. So this is x squared. Never mind about the rest over 2x squared down. So comparing the degrees, x squared and x squared, they are equal. So just we divide the coefficients 1 and 2. So the answer is 1 over 2. B, we need to remember that when you divide a number by infinity is 0. So x going to infinity, 3 over infinity, 0. 2 over infinity square is 0. 5 over infinity is 0. So we have 0 over 0 plus 2, which is 0. So 0 divided by 0, 0 divided by 2 is 0. C, the same thing. I don't need to multiply all of them. Just I need x and x. Remember, we are comparing the degrees of x. I don't need the others. So x times x is x squared. Down also, I don't need to apply the x plus 4 to the power of 2, which is a squared plus 2ab plus b squared. I don't need all of it. I just need x squared. So this is x squared. About the rest, I don't care. And dividing the coefficients, 1 divided by 1, which is 1. D, when x goes to infinity, this is 0 and this is 0. So the result is sine 0 minus 0 is 0. Sine 0 is 0. Ln x goes to infinity, the degree here is 2, the degree here is 2. So 1 divided by 1, which is 1. Ln 1 is 0. The same thing, e to the power, the degree here is 1 and the degree here is 2. So the degree up less than degree down, so the answer is 0. E to the power 0 is 1. Tangent ln. So tangent ln. When x goes to infinity, degree 1 and the degree is 1. So 2 divided by 2, which is 1. Tangent ln 1 is 0. Tangent 0 is 0. H, when x approaching infinity, number to the power infinity or e to the power infinity is infinity. Number or e to the power negative infinity is 1 over e to the power infinity, which is 1 over infinity, which is 0. So this is infinity and this is 0. Infinity minus 0 is infinity. 0 from the right, and remember here, e to the power 3 over 0, which is e to the power infinity, which is infinity. The point is, I need to know plus or minus infinity. That's it. So what we do is 0 from the right, it means positive. So 3 divided by a positive number, very close to the 0, is positive. So e to the power infinity, positive infinity, not negative infinity. And the answer is infinity. J, x approaching 0 from the left. 0 from the left, it means less than 0. Less than 0, that is negative. So 6 divided by negative is negative. So e to the power negative infinity. And e to the power negative infinity is 0. K, x approaching 2 from the left. If we replace just 2, it will be 2 plus 2 over 2 minus 2, which is 4 over 0, which is infinity. So the answer is infinity. Plus or minus, we're going to see. So replacing number less than 2. So let's say 1.99 plus 2, 1.99 minus 2. This is positive and this is negative. So positive divided by negative is negative. So the answer is negative infinity. Two from the right, if we replace 2, it's going to be ln 2 minus 2 over 3, which is ln 0. And we know it's infinity. So positive or negative, we're going to see. So 2 from the right, it means number greater than 2. So let's say 2.001 minus 2 over 3. This is positive and this is positive. So it's going to be positive ln of 0 from the right. As we mentioned, ln is graphically like this. So 0 from the right is this side. So the function is going down, يعني negative infinity. M, as x approaches 5. So if you're replacing, you are getting 0 over 0. So we need to discuss from the left and from the right. Absolute x minus 5, when x is greater than 5, is going to be positive. So it's x minus 5. This is 5 from the right. X minus 5, when x is less than 5, 4 point something, is going to be negative. So negative x minus 5 when x less than 5, yeah, 5 from the left, which is negative x plus 5. So I need to discuss both cases. When x approaches 5 from the right, as we mentioned, it's going to be x minus 5 over x minus 5. So cancelled, which is 1. Limit when x approaches 5 from the left, we said x minus 5, and the one down is going to be negative, so negative x minus 5. I don't need to expand since x minus 5 by x minus 5 cancelled. It's going to be 1 over negative 1, which is negative 1. From the right is different from the left. So limit, when the limit from the right doesn't equal the limit from the left, it means the limit as x approaches 5 does not exist. And one from the left, so if we replace 1, it's going to be negative 7 over 0, infinity. So whether from left or from right, it doesn't matter because we have to the power of 2. So this is always positive, whatever you have here, because of degree 2. So negative 7 over, which means negative infinity. Or e to the power 4 minus 4 divided by 4, so e to the power 0, which is 1. P, when x goes to 0, 0, 0 plus 5 to the power of 2 minus 25 is going to be 0 over 0. And 0 over 0 is I and D. And we have to do something. So let me expand to x. So this is x squared plus 10x plus 25 minus 25. So 25 with 25 is cancelled. So it's going to be 2x over x squared plus 10x. Factoring over x with x power 2. So it's going to be 2 over x plus 10. Replacing 0, 2 over 0 plus 10, 2 over 10, which is 1 over 5. Q If you replace 2, it's going to be 2 plus 2 over 2 minus 2, which is 4 over 0, which is infinity. Just I want to know positive or negative infinity. So 2 from the right greater than 2. So 2.001 plus 2 over 2.001 minus 2. This is positive and this is positive. So positive divided by positive is positive infinity. The last one is Q. When x goes to 1, so 1 minus 3 divided by 1 square minus 2 bracket 1 plus 1. Going to be negative 2 over 0. Negative 2 divided by 0 is negative infinity. For question number 2, find the domain. Domain not related to factoring. So whatever the denominator is, solve it. So either by factoring or mod 53. So x and x, negative 4 and positive 2. So x equal 4 either or x equal negative 2. So the domain is all real numbers except 4 and negative 2. Find all the vertical asymptotes. As we mentioned, there's no factoring up, so it stays the same. So the vertical asymptotes are 4 and negative 2. So x equal 4, x equal negative 2. The horizontal asymptote, according to the degree of the numerator and denominator, degree 1, and the degree here is 2. So the horizontal asymptote is y equal to 0, degree up less than the degree down. Question number 3, also about vertical asymptote. So here we need to factor. So x GCF, x squared plus 2, x minus 24, x GCF into x minus 1. So x into 2 parentheses, x and x. The two numbers are positive 6 and negative 4. X into x minus 1. X cancel. So the only vertical asymptote is x equal 1. Horizontal asymptote, degree up greater than the degree down. This is the third case where we don't have horizontal asymptote. Number 4, it's about the cost of a certain company. What happens to the cost as production approaches 5? So if x is 5, then this is going to be 5 minus 5, 0, which is not accepted, or 10 divided by 0 is infinity, meaning the cost will go higher and higher, which is nonsense for the company. So it can't be 5. Explain why the rational function can cross its horizontal asymptote but cannot cross its vertical asymptote. Vertical asymptote, let me take an example. So let's say we have x over x squared minus 1. If we need to find the vertical asymptote, it's about the denominator. If you solve it, factoring mod 5 3, you're going to get x equal 1, x equal negative 1. The vertical asymptote is are the restricted values. X cannot take these values. It's out of the domain. That's why it's impossible x to be 1 or negative 1. According to the horizontal asymptote, the degree here is 1 and the degree is 2. So the horizontal asymptote is y equal to 0. I'm going to show graphically and algebraically. If you replace y equal to 0, is it possible to find x? Let's see. So 0 is equal x over x squared minus 1. If you cross multiply, then you're going to find x equals 0. So it is possible that the graph crossing the horizontal asymptote, showing graphically, see the graph, the middle one, the red one, crossing the x-axis, which is the horizontal asymptote at 0, 0. So it is possible the graph to cut the horizontal asymptote. Number 6. At what values of x does the graph of h have vertical asymptote? Let me simplify h of x. So factoring -5 and +4 ln x and x +5 and +5 GCF x into x plus 5. So x plus 5, x plus 5, x plus 4, x plus 4 is going to be x minus 5 ln x plus 5 over x. Okay. For the vertical asymptote, the denominator is x, so x shouldn't be 0. So the vertical asymptote is x equal to 0. And if you replace x equal -5, because we have the ln shouldn't be 0 and shouldn't be negative. So if you replace x by -5, it will be ln of -5 plus 5, 0 over -5, which is not allowed. So the vertical asymptote x equal to 0 and x equal -5. Number 8, difference quotient rule. Limit f of x plus h minus f of x over h when h approaching 0. And the x is 3. So limit h approaching 0, f of 3 plus h minus f of 3 divided by h. So I'm gonna replace 3 plus h in the function. So 3 plus h to the power of 2 minus f of 3, which is 3 square over h. Expand according to the formula a square plus 2ab plus b square. So 9 plus 2 times 3, 6h plus b square, which is s square, minus 9 over h. Plus 9 or minus 9 cancelled. Also h from here, h from there, and with the power of 2, it will be 6 plus h. When h approaches 0, so 6 plus 0, which is 6. Let me erase. Number 9, given the function, find the average rate of change f of b minus f of a divided by b minus a. This is a and this is b. I'm going to replace 3. So it will be 3 square minus 5 times 3 plus 1 minus bracket, replace 1. It will be 1 square minus 5 bracket 1 plus 1 over b minus a, 3 minus 1. Do calculations. It will be negative 1. Number 10, a car's position is given by this equation. Find the average rate of change between t equal 2 and t equal 5. So it's going to be the same thing. F of 5 minus f of 2 divided by 5 minus 2. So also I'm going to replace 5. It will be 4, 5 square plus 3 into 5 minus bracket, replace 2, 4 bracket 2 square plus 3 into 2. We'll divide by 5 minus 2, 3. And the answer is 31. What does this value represent in context? In general, the derivative regarding physics represent the velocity in general. So we're talking about the average rate of change. So here it represents the average velocity. For question 11, use the limit process, which is the definition of the limit. Before I would like to mention something for question number 3. There is a typical mistake I corrected by default and I considered it's nonsense, so I did not focus on it. This is both of them, they have the same power, which is nonsense. So I consider this is power of 2, and I solve the question according to this. So let's start with number 11. The limit process, or the definition of the limit, is limit when h approaches 0, f of x plus h minus f of x divided by h. So part A, the f of x plus h, we plug in x plus h. So it's going to be x plus h squared minus 2 into x plus h. Let's simplify according to the formula a squared plus 2ab plus b squared. So x squared plus 2xh plus h squared. Multiply, so negative 2x, negative 2h. I'm going to replace it in this formula. So limit when h approaches 0. So x squared plus 2xh plus h squared minus 2x minus 2h minus f of x, so minus open bracket, the function itself is x squared minus 2x divided by h. That's equal to h approaching 0. So I'm gonna multiply, it will be negative x squared and positive 2x. Simplify, positive 2x, negative 2x, negative x squared and positive x squared. So it's going to be 2xh plus h squared minus 2h divided by h. Simplify h with power of 2 and h. The remaining is 2x plus h minus 2. Finally, replace h by 0. So this is going to be 0, 2x minus 2. Part B, also I'm going to get fx plus h, which is 1 over bracket x plus h minus 2, which is 1 over x plus h minus 2. Replace limit when h approaches 0. 1 over x plus h minus 2 minus f of x 1 over x minus 2 divided by h. Remember when we add or subtract fractions, so let's say 1 over 2 minus 2 over 3. The best way is same denominator, 2 times 3, which is 6, and then we cross multiply. 3 times 1 minus 2 times 2. So it's equal to x plus h minus 2 multiplied by x minus 2. First multiply x minus 2 times 1, x minus 2, minus open bracket. It's important, minus to open bracket. This multiplied by 1x plus h minus 2 over h. Simplify. So x plus h, the denominator keep it the same, don't touch it. Here we're gonna have minus x and minus h and plus 2. Simplify the plus 2 with the minus 2, the minus x with the plus x. So the remaining is negative h. Divide by h. I'm gonna put over 1. So the h with the h cancelled, and the remaining is 1 over x plus h minus 2 and x minus 2. If you are asking about this, remember if you have mixed fraction 1 over 2 and 3 over 5, you can say far times far, near times near. So 1 times 5 is 5 over 6. This is how you convert mixed fraction into fraction, or complex fraction into fraction. So replace now h by 0. This is gonna go. So it will be 1 over x minus 2, x minus 2, which is negative 1 over x minus 2 all squared. So let's do part C. I'm going to get f of x plus h, plug in x plus h. So square root x plus h minus 2. Replace limit when h approaches 0. Square root x plus h minus 2 minus f of x itself, x minus 2 over h. A question contains square root, we need to rationalize. Now to rationalize, we multiply by the conjugate. So radical x plus h minus 2 minus radical x minus 2 over h multiplied by the conjugate. The conjugate is the question itself, minus 2, changing the sign in the middle, plus, and inside the radical we don't touch, up and down. Okay, how do you multiply? The conjugate, we multiply the first by the first and the second by the second. When you multiply the radical by itself, the radical goes. So x plus h minus 2 minus, important to put to open parentheses. Radical x minus 2 times itself, the radical goes. Down, they are not conjugate, so we keep them the same. Don't touch. Plus x minus 2. Simplify. Negative times x, negative x, negative times negative 2, positive 2. Simplify negative x, positive x, positive 2 and negative 2. The remaining is h, and h cancelled, so it's equal to 1 over radical x plus h minus 2 plus x minus 2. When h approaches 0, it's equal to 1 over radical, the h goes 0, so x minus 2 plus another x minus 2. So 1 over radical plus itself, 2 radical x minus 2. The last question, number 12, sorry, still 12 and 13. Estimate derivative at x equal 3. This is the last lesson, 2.3. So 3, it's not one of the numbers, so it's between 2 and 4. So we take estimate. This is the y and this is the x. So y2 it's 10 minus y1 is 3 divided by x2 is 4 minus x1 is 2. So 7 over 2. The last question. Suppose f x continuous IVT theorem. How would you use the derivative or tangent line slope to approximate the root more precisely? I'll tell you the story about this. Suppose we have the graph for any function. The zero or the root is here, and we don't know exactly what the root is. So we use this method, derivative, to approximate the root. So what we do is, or the theorem based on, we take a value of x close to the real root, and then we draw the tangent at this point. The tangent cuts the x-axis at a certain point. This point is supposed to be close to the real root. And then what we do, we take another point, as we go closer to the real root, we do the same thing, and we draw a tangent line at this point, crossing the x-axis at a point that is very close to the real root. We continue this process until we are very, very close to the real root. Part B, how is continuity essential for the IVT? It is very essential, since the IVT says that if you have a negative f of b and positive value for the function, then the IVT guarantees that there will be a root between a and b. This is in case the function is continuous. So if the function wasn't continuous, so let's say this is b and this is a, even we have one negative and one positive, never mind who is a, who is b. So if we have jump at a certain point, then we are not sure, or we cannot guarantee that we have a zero between a and b in case we have a jump. So the function must be continuous to guarantee that there will be a value between a and b.